Okay, today's video is going to show you how you can write a linear equation using a table of values. So we have our table of values here. We have an example. I have my x values here on the left-hand column, and I have my y values here on the right-hand column. So the first thing I need to look at is the relationship between how my x is changing and how my y is changing from point to point. Okay, so we'll start off with how my x is changing. From my first point to my second point here, x has gone from 1 to 2, so it's increased by 1. And over here, when we go from my first point to my second point, my y value has gone from 4 to 7, so it is increased by 3. Then we check from my second to my third point. X is going from 2 to 3, so it's increasing by 1. Y is going from 7 to 10. Again, it is increasing by 3. And again, we have an increase of 1, and we have an increase of 3. So this tells us already that yes, this is a linear equation because my x and y values are increasing constantly, like on a consistent proportional rate. For every 1 that my x increases, my y increases by 3, and that pattern continues. If, for example, my x was increasing by 1 every time, but my y was increasing by maybe 3, then 6, then 9, because the increase is not consistent, that would not be a linear equation. But in this example, because both my x and y are increasing at a consistent rate, then we know that this is a linear equation. So we have our relationship here. We're saying for every 1 that x increases, y increases by 3. So y is increasing 3 times faster than x. Or in other words, it takes 3 x's to make up a single change in y. So we can write this as y equals 3x, because it takes 3 of these x's to equal 1 of these changes in y, or y is increasing 3 times faster than x. So that's where we start with our equation. We start by writing kind of the relationship between the change in y and the change in x. So we've got y equals 3x. Now, our equation is not quite complete, but we need to kind of check and see where we're at. So what we can do, we can take this equation and test it out. So we're going to pick a point on our table of values. We may as well start with the first one, this 1, 4. And we're going to substitute our x value into the equation and see if we get the output of the y value. So remember we talked last week about input and output. So with this equation, if I input a 1 in place of the x, I should get an answer of 4 for my y. So let's try it. Y equals 3 times, instead of x, I'm going to substitute a value of 1, and I should get an answer of 4. So let's try it out. Y equals 3 times 1 is 3. So I did not get an answer of 4. So I know that something's wrong. My equation is not yet complete, because with this table of values, when I input x as 1, I should get an output of y equals 4. But instead what I got, when I input x equals 1, I got y equals 3. So I'm a little bit off. In fact, I'm 1 off. I have 3, but I want to get to 4. So I'm going to go back and adjust my original equation. I'm just going to add 1 to it. And we're going to see if that has solved our problem. So I had 3, I wanted 4. So I'm going to just try adding 1 to my equation. So now I'm going to try again. I'm going to test it out again. I'm going to input a value of 1 in for x. With my new equation, I now have a plus 1. And I'm going to see if this equation equals out to y equals 4. So y equals 3 times 1 is 3. And I keep my plus 1. Y equals 3 plus 1 is 4. So that one does work out. When I input x equals 1, I get y equals 4 for my answer. And I can try it again with another point. Let's try the next point, this 2 and 7. So when I input x equals 2, I should get an answer of y equals 7. So instead of an x, I'm going to now put in a 2. And when I work it out, I should get y equals 7 according to my table. 3 times 2 is 6. And then 6 plus 1 is 7. So I do get an answer of y equals 7. So now my equation is complete. So I started off by checking the relationship between my change in y to my change in x. And I said that it takes 3 x's to make up one change in y. And then I tested that equation and I saw how much I had to add or subtract from that to actually get the answer that I wanted. And so I ended up with 3x plus 1. So let's try one more. We'll do a new table of values here. So let's try this. Negative 1 and 2, 0 and 0, 1 and negative 2, 2 and negative 4. Okay. So let's see, how much is my x value changing? From a negative 1 to a 0 is plus 1. From 0 to 1 is plus 1. From 1 to 2 is plus 1. So again, my x value is increasing by 1 every time. Let's look at my y. My y is going from 2 to 0, so it's going minus 2. 0 to negative 2 is again minus 2, and negative 2 to negative 4 is another minus 2. So I'm looking at what is the relationship between how my y changes and how my x changes. So this one I can say y equals negative 2x. Okay, so it's changing for every 1 that x changes, I have a negative 2 change in the y. Okay, so it's changing twice as fast, but it's at a negative value. So y equals negative 2x. So I'm going to test that one out. I'm going to put in my input of x equals negative 1 and see if I get an answer of y equals 2. So y equals negative 2 times, here's where I put in my value of x, negative 1. And when I input a negative 1x, I should get an output of y equals 2. Let's see. Negative 2 times 1 is 2. So that one does work. Okay, that is my equation. I don't need to add anything to it. So I can test it out again with another one just to see. If I put in a 0, I should get an answer of 0 for my y. So negative 2, I substitute in 0. Negative 2 times 0 is 0. So there's my answer. Y equals negative 2x is my equation for a line.